We're going to get into lesson 212 today. This is our open response lesson where our focus is to use the ratios we've been using and using our knowledge there to help us solve a bigger, more complex problem that deals with ratios. So we're going to do a quick review here of a little situation to kind of get us ready for that bigger situation. You'll be doing similar things. Okay, so make sure in your journals you're following along with us here, or you're going to be filling these out as we go on your slides. Okay, Arturo is mixing paint colors for props in school play. So to make enough pink paint for one flamingo, he's going to need 3 cups of red for every 2 cups of white paint to get that pink color that he wants. So the ratio, he wants red to white, so we got to make sure we do it in the right order. So that is 3 reds to every 2 whites. So that would be a 3-to-2 ratio. Some people like to label that red to white just to kind of remind them underneath there of the order that we need to be in. In this case, it's that 3-to-2 ratio that we need to keep that same color of pink that we're trying to make. So in the case on B, what is the paint ratio of red paint to total? So this was part to part. Now we want part to total. So we know for red paint here, we have 3 reds. Now compared to the total, I have to add up the red plus the white. So this would be a 3-to-5 ratio if I look at it from part to total. So 3 out of every 5 have to be red. So that means the other 2 would have to be white, which matches up with our ratio here. Some of you know too that would, if you really know and understand percents and fifths, 3 to 5 ratio, that would be 60% of the paint would be red. So 40% of the paint would be white to get that perfect mix of color. So different ways you can think about that there. C, if Arturo paints 2 flamingos, how many cups of each color will he use? So 2 flamingos, well, I know one is 3-to-2, so I can do what we talked about the other day, and I can double these because I'm doing 2. So that would change to a 6-to-4 ratio. If I do 3-to-2, 3-to-2 twice, that gets me a 6-to-4 ratio. So we could do it that abstract way. You know, I could draw pictures and use tiles and do those things too, but it should be pretty easy to double in that case, so I'd probably use that strategy. Question D. Now what if we get up into Arturo painting 6 flamingos? Okay, so I'm probably not going to want to draw a picture of 3-to-2, 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 and do that 6 times. All right, so that tape diagram that we talked about earlier this week could be a good one to use. Okay, so I'm going to flip over screens here, and you guys can draw this. If we're looking down here at this part on for D, if I do a tape diagram, remember, it's a 3-to-2 ratio, so we're going to label red and do 3 pieces of tape. So you guys can be doing that now. And then white and do 2 pieces of tape. So you guys would just make the tape to get going here, and they'd be blank to start. Okay, so how do I know to get 6 in there? Well, they told me up here that I'm doing 6 flamingos. And remember, the number I'm in there is how many times I need to do this rate. It's a 3-to-2 ratio, and I want to do that 6 times because I'm painting 6 flamingos. So that's why we put 6 in there, and then that'll give us a ratio of reds. I would need 18 cups because 6 times 3 is 18, so I'll write it up here above, 18, and then that would be 12 of the whites. And 18 to 12, then I would then know that I would need 30 cups of paint total if I needed that information. 18 reds, 12 whites in this case. So now I know how much paint I would need to go out and buy in order to get this done and get these all painted. So the tape diagram here is probably easier than a big picture. I could have also, if I know it's a 3-to-2 ratio, the abstract way, I know I need to do that 6 times. I just take this times 6. And I take this times 6, so it becomes 18 to 12. And again, eventually most of you will be doing that a lot of the time probably. Tape diagrams are another great option for that, probably better than drawing a big picture, you know, and doing that rate over and over. That gets to be pretty time consuming, okay? But you could do that. If we look, I'm going to erase this now here, and we'll pause it if we need to when we're watching this video so you guys can get those written. But another way to look at this, again, the picture that probably takes a little longer. I don't think I'd probably do it this way, but 3 reds for every 2 whites, and there would be my 1 flamingo that would paint. And I have to do this 6 times in a row, and then I could figure out the total by adding all these up, and I still get 18 of those reds to 12 there. Okay, so we've talked about all these different ways to deal with ratios, and you're going to be using those today in your open response in a more complex problem to solve a real world problem, having to use this type of ratio thinking.